second half of the review for Chapter 6, Probability. You should see a table on your review that looks like this. This is males and females age at a college. A, what is the probability that the student is a female? So we want to add all of these up. 31, 476, 315, 120, and that is 942. That's how many females there are. How many total students? Hopefully is 1797. Done. That's all we need to do. B, what is the conditional probability that the student is a female given that the student is at least 23 years old? So that would be this column right here. There are 195 23 and older people. That is the given. The given is in the denominator. So the denominator is 195. I'm only going to be looking at that column. I'm only going to be looking at 23 and above. How many of those 195 are females? 120. Next problem. C. What is the probability that the student is either a female or at least 23 years old? So we have to include all the females. First of all, the denominator is the total. 1797. That's the total. It's not given, no conditional probability. And then we need to count females. So we're going to count 31, 476, 315, 120, or anyone that's 23 or older. So it would be this group. So those those five numbers added together, I believe, make 1,017. So females, and then this one, making sure we do not count that 120 twice, we only want to count it once. So there's probability with like a table. And then moving on to dice. Keep going. Oh, too far. If 3 dice are rolled, find the probability of getting triples. Fairly simple and straightforward. There are 3 different numbers on the first roll. I'm sorry, there are 6. There are 6 different numbers on the first roll. There are 6 different numbers on the second roll. And there are 6 different numbers on the third roll. What do we do when they happen in sequence? We multiply. So there are 216 different possibilities. That is our denominator, 216. Now I'm going to list the triples. 111, 222, 333, 444, 555, 666, and that is it. 6 out of 216. If 3 cards are drawn from a standard deck of playing cards and not replaced, that's very key, not replaced, find the probability of getting at least 1 heart. I'm going to, since I see the phrase at least 1, I'm going to say, you know what? I'm going to do the opposite. I'm going to go 1 minus the probability of none. 1 minus the probability of none. And that'll give me my answer of the probability of at least 1. So, probability of none. There are 39 cards that are not a heart out of 52. If I pull one out and it's say a diamond, and I put it to the side, it's not replaced, then I have 38 cards that are not hearts out of 51. And if I do it again, it's 37 out of 50. So that should be 1. This turns out to be, let's see, I think I might need to get a calculator. I thought I did this ahead of time, but I did not. Sorry, I can stall though. Today is my daughter's birthday. I'm sure that matters a lot to you. She's turning 3. Not 2. She's very excited that she's not 2 anymore, but that she's 3. Sorry, getting a calculator up. All right, so let's see. Get rid of that. 39 times 38 times 37 is that number. 52 times 51 times 50 is that number, and I'll divide those. 5, 4, 8, 3, 4 divided by 1, 3, 2, 6, 0, 0 is 41%. So that's not my answer. I need to take 1 minus that. 1 minus 0.41 equals about 59.